suddenly Heron's formula, this formula is also, just a second. Okay, Heron's formula. Here, what are we going to discuss? Here we will be discussing there is a magical formula which is given by the mathematician Herons. Okay, so that formula only we will be taking, and that formula is related to finding the area of the triangle. Now you must be thinking, already we are having in hand one formula for finding the area of the triangle, that is 1 by 2 times base into height, right? Area of triangle. We can find by using the formula 1 by 2 times base times height. Then what's the need of a new formula? This formula was fulfilling our purpose. Whenever we wanted to find the area of the triangle, we were using this formula very easily just by doing the multiplication and calculation. We were getting the area. So why we are going to learn a new formula given by a mathematician Herons? So let me show you why we need to just why we need a new formula, why we need to discuss this topic. Let me show you a scenario. So basically we are having three types of triangle, as you already know: the scalene triangle, isosceles triangle, and equilateral triangle. Now, if we will be having one example of a scalene triangle, I can take one triangle like this, where we are having one of the side as a 3 centimeter, another side as a 4 centimeter, and the third side as a 5 centimeter. As you know, a scalene triangle means a triangle where all sides are of different length. If we are talking about an isosceles triangle, then we can take a triangle where this side is 5 centimeter, this side is also 5 centimeter, and this is total, let's say, let me take the data properly so that it will make the calculation easier. Now only we are going to do few calculations over here. Just give me a second.
Okay.
Here we are having 8 centimeter total. Now, even though it doesn't look like that, let's assume that the base is 8 centimeter. Now, equilateral triangle, we can take the measurement like this one: 6 centimeter, 6 centimeter, and 6 centimeter. Now, if we have to find the area of these triangles, okay, so you already know the formula is 1 by 2 times base times height. If we are going to talk about the first triangle, that is a scalene triangle, here base, you can take any of the side as a base, but what about height? So you must be thinking, yeah, we can drop a height. We can draw a height like this. If this is a triangle ABC, then we can draw a height like this, and we can name it like AM. But the main question is how we will be finding this AM. So that is the main thing, which like first we need to find the height, and we need to check whether that is also possible or not. Is it possible to find the height in this triangle or not? That we need to check. If that is possible, then we will be taking out the height, and then we can go ahead and we can find the area of the triangle. So let's keep it aside for a while, the scalene triangle. Let's discuss about isosceles triangle and equilateral triangle at first. Okay, we will be getting back to scalene triangle. So for isosceles triangle, if we are having a triangle PQR, here also for finding the area, what we need base and height, because now Till now we have not discussed about any new formula, magical formula. We are having our older formula in hand, that is 1 by 2 times base into height. Okay, so according to this formula, for finding the area, we need base, we need height. Let's drop the height. Let's name it Pn. Okay, now we need to find the height Pn. But we know there is a theorem in isosceles triangle that whenever we are dropping a perpendicular, it will bisect the other side. Okay, the side QR will get bisected, or you can say n is the midpoint of the side QR. There is a theorem from where suddenly this theorem came out. So if you already know the concept of congruency, you can see this PQN triangle and PRN triangle will be congruent to each other. Okay, from there only this formula came out, that once we are dropping a perpendicular in an isosceles triangle, it will bisect the other side. So side QR is getting bisected. QN and NR both are same. Okay, so this is what we already know. Now since Q and QR are both are same, or n is the midpoint of the QR, if this total side measurement is 8 centimeter, we can say this much is 4 centimeter and this much is 4 centimeter, right?
Ma'am, can you repeat once again? I'm sorry, I didn't hear it properly.
Yeah, what?
Can you repeat it once again? I didn't hear it properly.
Yeah. I am saying that in an isosceles triangle, whenever we are dropping a perpendicular, then that
Okay.
perpendicular will bisect the other side. Okay,
Okay.
that
Yeah.
perpendicular will touch the midpoint of the other side. So here we have dropped the perpendicular PN. So it is this N will be the midpoint of QR. That's what there is a theorem in isosceles triangle. From where this theorem came, it came from the concept of congruency. You will be able to prove that the left hand side triangle and the right triangle, both the triangle are congruent with each other, and hence this Qn and Nr will be the corresponding part of the congruent triangle, and hence both will be equal. From there only this theorem came out. Okay.
Okay.
Okay, ma'am.
So n will be the midpoint. On the basis of that only I am saying, if total length of QR is 8 centimeter, then QN will be 4 centimeter, NR will be 4 centimeter. Yes or no? This is also 4
Yes.
centimeter and this is also 4 centimeter. Right?
Yeah.
Now we can
Yeah.
take any right angle triangle. Why we need to take right angle triangle? Because we want to find the length of PN, the length of the height. What is the height that we want to find? So you can take any triangle, right angle triangle, either the left one or the right one. You can see here we are having 4 centimeter. You can see here we are having 5 centimeter. The name is PNQ. And from here, from this right angle triangle, we need to find Pn. How? By Pythagoras theorem. Okay. So
Okay.
by Pythagoras theorem, we can say what can we say by Pythagoras theorem? Anyone?
Um,
Hypotenuse square is equals to base square plus height square. That means PQ square is equals to PN square plus QN square. Do you know this theorem?
Yes, ma'am.
Ma'am.
So PQ is what? 5 square. Pn, we wanted to find Pn square. Qn is 4 square. Let's do the calculation. So we will be having 25 is equals to Pn square plus 16. Pn square will be 25 minus 16. That means Pn square will be 9. And Pn we got from here as 3. We wanted to find the height so that we can go ahead and we can find the area of this triangle. Once we got the height Pn as a 3 centimeter, now we can find the area of the triangle by using the area formula, that is 1 by 2 into base into height. So area will be area of triangle PQR will be 1 by 2 into base. Base is QR into height. Height is Pn. 1 by 2 times QR is 8 and Pn is 3. 2 4 times 8 and we got area as a 12 centimeter square is the unit of area. This is how we got the area of the triangle PQR. Is it clear?
Yes, ma'am.
Similarly, we can also find the area of the equilateral triangle. The theorem which I was telling for the isosceles triangle, same theorem is applicable for equilateral triangle also, that whenever you will be dropping a perpendicular, that perpendicular will bisect the other side. So this will also become 3, this will also become 3. This is only applicable for isosceles triangle and equilateral triangle. Why this is only applicable for isosceles and equilateral triangle? Because you can see here, once we are having, let's say, a equilateral triangle, here is here a b c, as it's an equilateral triangle, and I am saying side a b b c c a all are same. Okay, and we also know, if we will be dropping a perpendicular over here, let's say the name of the perpendicular is am. This is perpendicular we are dropping. If we have to prove the triangle ABM, have you done the chapter triangles?
Yes,
Yes,
ma'am.
ma'am.
So if we are taking triangle ABM and triangle ACM, let's see, AB over here and AC over here, both are same since it's an equilateral triangle. Now here 90 degree, there 90 degree. So we can say angle AMC is equals to angle AM. Okay, angle AMB is equals to angle AMC. Both 90 degree because we have dropped a perpendicular. Now what else are same? So since AB and AC are same, therefore angle ABC and angle ACB both will be same, right? If two sides are same, opposite to those side, whatever angles are there, those angle will also be same. We have learned this concept in isosceles triangle, right?
Yes.
So this is also, so what are we getting? We are getting this angle and this angle same. So what, okay, one more thing you can say, if you don't want to take this angle, you can say there is a common side AM. Can you see? In both the triangle, AM and AM is a common side. Can you see?
Yes, ma'am.
And hence both the triangle are congruent with each other. This triangle and this triangle are congruent with each other. Why I am showing you this one? Because suddenly I am telling you, you will be dropping a perpendicular and the perpendicular will bisect the other side. You must be thinking from where this theorem came out. So that's what I am showing you, that from here only this theorem came out, that these two triangles are congruent and hence their corresponding part will be equal. What are the corresponding part? The corresponding parts are this. This is side BM and side CM will be equal with each other by CPCT. That's why I'm saying that BM CM will be equal once we are dropping a perpendicular. Getting it?
Yes, ma'am.
And here you can see by RHS congruency, we are saying that it's congruent. So this theorem only I have used for isosceles triangle also. And this theorem only I am talking about for equilateral triangle also. That once we are dropping a perpendicular, it will bisect the other side. This is 3, that is 3. Let's say the name of the triangle is MNO. And here we are having P as a middle point. Now, just like the previous case, isosceles triangle, here also you will be able to find the height. Why we need to find the height? So that we can go ahead and find the area of this triangle. Okay, so first we will be finding the height MP, again by Pythagoras theorem. Okay, now after that we will be finding the area of this triangle. Let's quickly find the height of this triangle and then find the area of this triangle. So once we will be finding the height of this triangle, again, if we will be taking triangle M and P, here by Pythagoras theorem, we can say that hypotenuse square, that is 6 square, is equals to 3 square plus MP, that means height square. MP square will be 36 minus 9. That means 27. So MP will be root 27.
Okay.
Now area of the triangle will be, area of our triangle will be 1 by 2 times base times height. Base is 6, height we have, now only we found the height as a root 27. So 1 by 2, base is 6, height is root 27, and we ended up getting 3 root 27. Okay, and if you want to simplify root 27 more, you can just write 3 into 3 into 3. So 1 3 will come out from the square root. So you can do this calculation. 27 means 3 into 3 into 3. So a pair is there. For the pair, one number will come out. That means 9 root 3 is our area of the triangle. Is it clear so far?
Not confident now.
Where you are facing, like where you are having confusion?
So
We are just finding the height. Okay, we are having a triangle where each and every sides are given. Okay, what we are doing, what I want to show you, that in this triangle, just by using the older formula 1 by 2 into base into height, we can find the area. Base is given, all the sides are given, so we can take any one of them as a base. Height is given or not? Height is not given. So we are dropping a perpendicular and we are finding the height.
okay.
Okay, once we are having the height in hand, then we can go ahead and we can find the area of the triangle. How we are finding the height? So we are just dropping the perpendicular and we can see that perpendicular will bisect the other side. Hence we are getting a right angle triangle where we can use Pythagoras theorem and easily we are able to find the height. Okay,
Okay.
after getting the height, we are just doing the calculation to get the area. Now we calculated this. We calculated the area of the isosceles triangle by older formula only. We calculated the area of equilateral triangle by older formula only. How to find the area of a scalene triangle? So here, finding the height is not possible. Once you will be dropping a perpendicular, then the theorem which you have used for isosceles and equilateral triangle, that perpendicular will bisect the other side, that theorem is not valid for a scalene triangle. Why? Because if you will be taking a scalene triangle where all the sides are of different measurement, you won't be able to prove this two triangle are congruent. Hence, that theorem which we were using for isosceles equilateral triangle is not valid over here. Then how to find the height? It is not possible to find the height over here. And that's why we need something, we need a new formula which will help us to find the area of such a scalene triangle. Now, if you are thinking that till now you were using this formula only 1 by 2 into base into height and it was working very finely, then let me tell you that till now in each and every question wherever you were having triangle, height used to be given or it was possible to find the height. But when the height will not be given and even though it is not possible to find the height easily, then what we will do? And there comes Heron's. He said that use my formula. The mathematician says that use my formula, and my formula is a magical formula. It will help you to find the area of scalene triangle. It will also help you to find the area of isosceles equilateral. Whatever be the type of triangle, you can use my formula and you will be able to find the area. So when height is not known, when it is not possible to find the height, Heron's formula is the rescue. Okay? Even it is not it will not only help us to find the area of a scalene triangle. Heron's formula will also help us to find the area of isosceles triangle and equilateral triangle. Okay, so let's see what is that formula. So according to Heron's, the formula for area of the triangle is area of triangle. Suppose I am drawing one triangle over here, P, Q, R. Okay, where one of the side is a centimeter or a unit. You can take another side is b, and next the third side is c. What are this a b c? A b c small letter are the measurement of the side. Just like a can be 5 centimeter, 4 centimeter, 3 centimeter, 12 centimeter, anything. A is just the length of the side, B is just the length of the side, and C is also just the length of the side. We write it with a small letter. Okay. So if we know the length of each and every side of a triangle, then easily we can find the area of the triangle PQR. How? By using Heron's formula, and the formula is under root S, S minus A, S minus B, and S minus C. This ABC you already know, since I started with this one, that A is nothing but the length of the side, B is nothing but the length of the side, C is nothing but the length of the side. Now you must be thinking, what is this S over here? So S means,
Right.
just a second. S means A plus B plus C by 2. This is our S. What is A plus B plus C? Again, A, B, C are nothing but the length of each and every side added together, divided by 2. Okay. So now let's find the area of triangle, isosceles triangle, which we have already found. Okay. So isosceles triangle was having the measurement 5 centimeter, 5 centimeter, 8 centimeter. Let's find the area. We were having one isosceles triangle where this side was 5 centimeter, this side was 5 centimeter, and this side was 8 centimeter. We have already found the area of this triangle by using the older formula. But we are going to check. As Heron said, that my formula will work everywhere, be it a isosceles triangle, equilateral triangle, scalene triangle. If you know all the side of a triangle, then use my formula. So let's use Heron's formula. Area of the triangle is, area of triangle formula is under root S, S minus A, S minus B, S minus C. What is S? S means A plus B plus C by 2. What are A, B, C? A, B, C are nothing but just the length of each and every side. So let's add all the length. 5 plus 8 by 2. That means 18 by 2. That means 9. 9 centimeter we got as a value of S. Now let's put it in the formula. Which formula? This formula. Let's put the value of S. Let's put the value of A, B, C, everything, and let's calculate the area now. So let's do the calculation. We will be having area is equals to under root S. S is 9. This S I have substituted over here. Now S minus A. S minus A will be 9 minus. From here you can take any one as a, other one as a B, other one as a C. It's completely up to you. Okay. So I'm taking A as a 5. 9 minus 5. This is our S minus A. Now we need to do S minus B. So S is 9 and B is 5. Multiply, everything is in multiplication. Now we will be multiplying S minus C. So here I am going to write S is 9 and C is 8. Now let's do the calculation. So under root 9 9 minus 5 is 4. Again 9 minus 5 is 4 and 9 minus 8 is 1. Now to solve this square root, do you need to multiply all of them together? Please don't do the multiplication. Otherwise, it will be a very larger number. And you know that to solve the square root, we need to do the factorization, where we will search for pair, the numbers which are in pair. That will come out from the square root sign. So to solve it, please don't multiply 9 with 4 and then again 4. What you need to do, you can just break this 9 and you can write it as a 3 into 3. You can break this 4 and you can write it as a 2 into 2. And you can break the another 4 and you can write it as a 2 into 2. What about 1? Multiplication with 1 means the same thing. So I am leaving that one. So what will be the answer? Here 3 is in pair, 1, 3 will come out. Here 2 is in pair, 1, 2 will come out. And here also 2 is in pair, 1, 2 will come out. And we will be having 3, 2 times 6, 2 times 12. 12 centimeter square is our answer for the area of this isosceles triangle by using Heron's formula. Let's see, previously also have we got the same area by using the older method. So 12 centimeter square is the area of our isosceles triangle. You can see over here 12 centimeter square. Previously we have already found the area by using older formula, and you can see here also we have got 12 centimeter square. Getting it?
Yes, ma'am.
So
Yes,
from
ma'am.
if all the sides are given, so rather than doing this much of a step, easily we can go ahead and we can use Heron's formula. If you want to check it for your equilateral triangle, let's check it. So equilateral triangle we were having, where this side is 6, this side is 6, this side is 6. Let's use Heron's formula to find the area. So area of triangle, formula given by Heron is S minus A, S minus B, S minus C. What is S? S means A plus B plus C by 2. What is ABC? ABC are nothing but just the side of the triangle. So 6 plus 6 plus 6 divided by 2, again 18 over 2, that means 9 centimeter. Now let's put it in the formula of a area. So it will be under root, area will be under root S, that means 9, S minus A, that means 9 minus 6, S minus B, that means again 9 minus 6, S minus C, that means again 9 minus 6. Now let's calculate it. So we will be having 9, 9 minus 6 is 3, again 9 minus 6 is 3, again 9 minus 6 is 3. Now I told you, please don't do the multiplication. Just try to break each and every number over there. That will simplify your calculation. So we will be having 9 can be written as 3 times 3. And all the 3 I am going to copy paste over here. We got 1 3 in pair, another 3 in pair, and the last 3 is as it is. So we got 3 into 3 under root 3. This 3, which is just one, a single 3 is there, it got stuck inside the square root sign. So what we got as
Okay.
an answer? So our answer is 9 root 3 centimeter square. Let's check for equilateral triangle. Have we got 9 root 3 by using that height formula and everything? So here we ended up getting 9 root 3. What about there? Let's see. Can you see? Here also we have got 9 root 3. Can you see?
Yes, ma'am.
So here also we were once we found the area by using the older method, we have got 9 root 3 only. So from now easily you can use Heron's formula. Now the problem was scalene triangle. We were not able to apply the older formula over here. So for this scalene triangle, we need to use the Heron's formula because calculating height over here was not possible. So easily we can use Heron's formula once all the sides are known. So again, we can find the scalene triangle area by area of triangle ABC will be under root S minus A, S minus B, S minus C. Alright. What is S? S is A plus B plus C by 2. A is 3, B is 5, C is 4 by 2. You can take any one of them as a, other one as a B, other one as a C. Eventually, you have to add all of them together. So if you are adding 2 plus 2 plus 4 or 4 plus 2 plus 2 or 2 plus 4 plus 2, it's the same thing. That's why again and again I'm saying that you can take any one of the side as a, other side as a B, other side as a C. Okay. Now once we will be adding, we will be getting 5 plus 4, 9 plus 3, 12. 12 over 2, that means 6 centimeter we got as a S. Now we need to calculate the area by using S. Let's calculate it. 6 6 minus 3, 6 minus 5, 6 minus 4. Now what we will be having? 6, 6 minus 3, all are in multiplication, okay? So 6 minus 3 is 3, 6 minus 5 is 1, 6 minus 4 is 2. Now as I said to you, please don't do the multiplication. Rather than that, try to break each and every number so that you can search the pair. The number which are in pair will come out from the square root sign. So we will be having over here 6 as a, yeah.
What if we multiply with her breaking it?
You don't have to multiply 6 with 3. That is 6 3 times 18. 18 into 1 is 18. 18 2 times 36. Don't do the multiplication like that. Because here you are getting 36, which is a smaller number, and you will be able to figure out how you will be taking it out from the square root sign. But sometime, like in most of the cases, once we start solving the question from the exercise, once you will multiply everything, it will be a huge number. Just like it will be a huge number like 169. It will be a number like 625, 225. It can be more than that also, 2401, 2601, something like that. And then you will think about how to take it out from the square root sign. It will take some time. So better than that, just break each and every number. Now let me tell you what's the meaning of breaking the number. I am saying this 6, you can write it as
3 into
3
3.
into or 2 into 3. Yes or no?
Oh, yeah.
Right? Again, the other number. That is 3. If you want to break it, we can't break it. Okay? Break means factorize it. So we cannot factorize it. It's only 3. So we can just copy paste 3. 1 is there. So let's remove 1 because anything multiplied with 1 is the same thing. Now 2 is there. I'm copy pasting this 2 also because factorizing 2 is also not possible. Now we will be checking the pair, which number are in pair over here. So if you will see carefully, you can observe from here that here we are having 3, here we are having 3. 3 is in pair. So 1 3 will come out and 1 2 will also come out because 2 are also in pair. So 3 into 2 will come out and we will be having 6 centimeter square as the area of this scalene triangle, which was not possible previously. Now it is easily we are calculating the area by using Heron's formula. So Heron's formula is applicable for scalene triangle only? No, Heron's formula is applicable for any kind of triangle. Any triangle where all the sides are known, we can go ahead and we can use the Heron's formula. What about the older formula 1 by 2 into base into height? That formula we can apply only at such places where height, we already know the height or it is possible to calculate the height. Okay. Now,
Okay.
if you understand the meaning of here from Let me show you one more thing so that you will be having a clear idea and we can go ahead with the exercise question. Do you know what's the meaning, what's the difference between the perimeter and the area of any figure?
No, ma'am, I
Anyone
do not.
from here? Please let me know.
No, ma'am, I do not.
Do you know? Yes, any other student? बहुत गर्मी लग रहा है सुनो बहुत क्या हुआ ये गधेड़ी रीम है ये आके देखिए Am I audible? Can you
Yes,
hear me?
ma'am. Yes, ma'am,
Yeah.
I can hear you.
So yeah, can anyone tell me what is the difference between area and perimeter?
Ma'am, I don't know.
Yes, here few more students are there. Anyone? Alvina? Yes, Alvina. Am I audible to you? Can you hear
Ma'am, the
me?
inside part of the triangle is the area, and the out boundary of the triangle is the perimeter.
Yeah, exactly. The inside part of that triangle, if I am going to show you this part, this is the area of triangle here. Once we are painting this portion, that means I am painting the area of the triangle. Until now, the area which we were discussing, those are these areas only. Okay. So it's not only applicable for triangle, we can apply the same concept for any shape, be it a circle, be it a rectangle, be it a square. So area means this portion only, the inside part, and perimeter means the boundary only, the boundary. This boundary, this boundary, and this boundary. If we are walking, if we are just going along the boundary of any shape, that means we are covering the perimeter of that shape. If here I have started from point B, gone to A, then from A to C, then again C to B, that means one complete revolution we have taken, and that means we have covered the perimeter of this shape. So what's the formula for perimeter of a triangle? Perimeter of triangle ABC will be, what is the formula for perimeter? As you said, perimeter is nothing but just walking along the boundary. That means A plus B plus C. That is the formula for perimeter of this triangle. All right. Now let's take one question and solve it, which is related to area formula. We have just seen the area formula. The older formula we already know. The new formula we have seen. Okay. What about the perimeter formula? The perimeter of a ABC will be A plus B plus C. Okay. Just sum of all the side. Why? Because we are just moving along the boundary. First we move along. If we started from point B, then we just moved along BA, then AC, then CB. So what exactly we are doing? We move along BA and then AC and then CB. That means A plus B plus C. And that is the formula for perimeter of any triangle. You just have to find the sum of all the sides. Okay. Now let's take one question from here, which is related to the perimeter of the shape. Okay. So the question is, find the area of a triangle, two sides of which are 8 centimeter, 11 centimeter, and the perimeter is 32 centimeter. So let's read it carefully. It says that find the area of a triangle, two sides of which are 8 centimeter and 11 centimeter. As I said to you, you can take any one of the side as a, other side as a B. Let's go ahead. So let's take A as a 8 centimeter, B as a 11 centimeter. Do we know C also, so that we can go ahead and we can find the area of the triangle? So we don't know C over here. As you can see, the next information which is given is the perimeter. So yes, we know the perimeter, but C value, that means the third side length, is not given. And since we don't know each and every side, then how can we use Heron's formula? So this perimeter will help us to find the third side. Perimeter is given as a 32 centimeter. And now only, as you said, that perimeter means just sum of like walking along the boundary. So A plus B plus C value, we already know it's 32 centimeter. From here, A value we already know 8, B value we already know 11, C value we need to calculate from here. That will be, let's calculate it. So C we will be having 11 plus 8, that is 19, and 19 we will shift to other side. We will be having 13, 32 minus 19, that is 3 over here, and 13. Is it okay? Please check the calculation, everyone. Is it okay?
Yes.
Yeah. Now let's find the area of triangle. Area of triangle formula is under root S minus A, S minus B, S minus C. What is S? S is A plus B plus C by 2. Okay. So let's write it. S is nothing but A plus B plus C by 2. Do we know A, B, C? Yes, C was not given, but with the help of the perimeter, we found the C value as well. So let's do it. 8 plus 11 plus 13 over 2. 8 plus 11 is 19. 19 plus 13 is 32. 32 by 2 is what? 16, right? So we will be having under root 16. S is 16. 16 minus A we are having 8. 16 minus B we are having 11. And 16 minus C we have calculated 30. Let's calculate the area. All are in multiplication. Please be careful. Okay. So here we are having 16. 16 minus 8 is 8. Into 16 minus 11 is 5. Into 16 minus 13 is 3. Let's just do the multiplication. So we will be having under root. As I said to you, please don't do the multiplication. Rather try to break it. So 16, you can break it 2 into 2 into 2 into 2. Now, if you are thinking that how to break this 16, you can go ahead and you can do the factorization. Just like this one. 16, you can factorize to 8 times 16, to 4 times 8, to 2 times 4, and then to 1 times 2. So you got 4 times 2. Similarly, 8 we can break as a 2 into 2 into 2. into 5 into 3. Now search which numbers are in pair. So here, if you will look carefully, you can see this is in pair. Then if you will go ahead and you will check what else is in pair. So we can see this 2 is in pair. Okay, let me color it with different color. This is in pair. Next, this is in pair. Next, nothing else in pair. Okay, so whatever is in pair, let's take it out. So one number will come out from the square root, 2 will come out from here, one more 2 will come out from here, and one more 2 will come out from here, and under root what we will be having, 2 into 5 into 3. So 2 times 5 times 3. So we will be having answer as 8 under root 5 2 times 10 into 3, that means 30. That is our final answer, centimeter square or meter square, whatever unit is given, accordingly we will write the unit of area. So what was given? A value given, B value given, but C was not given. Instead of that, perimeter was given. So we have used the perimeter formula of a triangle and we found the C value, and then we have used Heron's formula for finding the area. When we will be using Heron's formula? When all the sides are given, or when it is simple to just get all the side, then we can go ahead and we can use Heron's formula. That will be the easiest. When base and height both are given directly in hand, then please don't use Heron's formula. Just use the older formula, that is 1 by 2 times base times height. Got it?
Got it, ma'am.
So this is how we will be using Heron's formula. However, this is just the basic formula or the basic discussion we have started about the Heron's formula, that this is the formula, this is how we will be calculating. But there are few more scenario where we will be seeing few more different types of question, or triangular park is there, all around it, boundary is there, something else, and then so there also we will be using Heron's formula, but uh, with like a quite a different scenario will be there. So first we need to understand the scenario over there, and then we will be using Heron's formula. But this is the base, like this is the base of that. You need to understand the base, you need to understand the plot of that, like from where the formula came, why we need to use this formula, why we are not going to use the older formula. So this is the concept related to that, and little bit introduction about the Heron's formula. I would have taken one more question to show you, but we will run out of time if I'll be taking that one. So I'm keeping it this much. Now you tell me where you are